Okay, gents, today I had a lesson with year 10 and they were looking at me like they'd never heard of electronics. Maybe it's Monday morning, maybe it was me moving too fast, I'm not too sure. But what I thought I'd do was just go through the program that we've been working on over the course of the last couple of weeks and some good housekeeping habits. And if you're a little bit unsure about any of it, I just explain why it's there and what it does. So, first of all, we've got this with dice on it. Um, that is the name of my flowchart. It's always good to have that not as start, but as something so we can refer to it later. As we go down, we're asking, is D1 pressed? Is D1 high? If it is high, we're going down to the randomizer. If it isn't, we're just going to go around in a loop. If we go to the randomizer, we're very quickly producing a number between 1 and 6. As you can see, the random number is on N number, and that goes between 1 and 6. It then asks, is my finger still on the PTM? If it is on the PTM still, then it goes and creates another number, and then another number, and then another number. So every time I press that PTM, we're probably producing a chain of, 20, maybe 200 numbers. And so I'm not in control of what number is going to come up next, because we know the numbers on the Genie are not random. They follow a given sequence of numbers, and we all saw that on the dice in our last lesson or so. Right, we go down and we've got the compare functions. You're very aware of this. N equals what? 1, 2, 3, 4, 5, 6. If it equals between 1 and 6, we've got different highs coming on. What I would do with these, just so you're really clear, is I would turn the rest of them off, just so we know we've got complete control. And then we've got a wait command just under those. Just a wait command just under those. Once we know that the number has been displayed on the dice, we wait for half a second, and then we go to something called buzz. What does that mean? Well, this is a routine, a subroutine. That's the word I'm looking for, a subroutine. So that will allow us, that is this one here, call. I've moved that in, and what I've done is I've double clicked on it, and then I've called it double clicked on it, and then what I've done is I've called it something. So now it's looking for that specific subroutine. It's looking for hello. It doesn't exist, of course, but that's what that function does. Now, if we go up here, what we can see is what subroutine buzz. Now, it has got a loop in it, and that's what this for and end loop is. Okay, so for 1 to n, n being the variable, the random variable, for 1 to n, what we're going to do is we're going to go high on Q0 and then low on Q0. And what is Q0? Well, Q0 is connected to my buzzer. So my buzzer is going to go high then low. So every half a second it's going to go high and low. And that will happen for n number of times. And so if n is 6, we'll have a beep, 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 which you can count. And hopefully, if you can't see it, you can hear it. All right, so let's just go and delete that or we'll get confused. After that, what happens? Well, we go low with everything here. Okay, and then we are going back to the top. There we go, back to the top to the dice. Right, I hope that explains what's been going on. I don't think I've tested this yet actually. Let's just see if this works. Okay, we've got our Genie in here, Genie 14. We've got 2 PTMs functioning it or connecting to it. We've got a D1 and D2. We've got our pull downs. We have our switch to turn on and off the circuit. And then we have the matrix of different LEDs. What I've done with these, if those two are going to come on together, what I've done is I've connected the highs. You see these two come on together, and what I've done is I've connected the highs. All the lows all go low, and then what I've done is I've taken the outputs from the Genie and I've connected it to that piece of cabling, that track, which connects both of the anodes. The anodes being like addition, being the positive one, and the cathodes being the negative leg on the LED. I should have said the positive leg, not the not positive one. What else have we got up here? We have a buzzer. There's not enough energy being produced by the Genie itself, to power the buzzer. So what we need to do is use a transistor. A transistor is an electrical switch. When it gets voltage here at this leg called the base, it allows electricity to pass through it. It starts at 0.6 volts and it finishes at 1.5. So at 1.5 volts, it's letting as much energy as it can across its component. Now there are 4.5, there's 5 in this circuit, sorry. However, you won't get 5 going across this transistor. Just to let you know, park that thought. I can go on and talk about that later. But it's probably about 4.2 going across that, which is more than enough to power the buzzer. So let's just take a look and see if it works. I think I'm voltage levels. No, current flow. Can't quite see. There we go. Current flow. So what are we doing? Just have a look at this. This one. You can just see it's a much better view. We can really work out where the current's going. So if I was to take that off, can you see that the current does not go to those components? So I've got everything wired up. It should be okay. I'm going to press this one, and then you can see there is a slight doesn't seem to be much of a differential between the buzzing. I'm just going to pop over to the flow chart and make sure that this is turning the buzzer. It is turning the buzzer off. Maybe it's just a program that is not reading that low as a low. Sometimes it doesn't, but it should go high for a quarter of a second, then low for a quarter of a second. Right, it seems to be working fine. So now I want to move on to the next part, and I'll explain that and then I'll come back to it in a bit. The next part is also going to be using a subroutine. Indeed, we're going to put this command here into a subroutine so we can call it. But the next part, what it does, it's called Snake Eyes. I want the Genie when you press a different PTM. So you've got 2 PTMs. When you press the other PTM, let's call that PTM2, and that's on D2, and the first one should be PTM1, and it's on D1. When you press PTM2, what happens is you start the Snake Eyes game. It will randomly show numbers between 1 and 6. If that number is number 1 and you press PTM1, that's PTM1, then what happens is you have succeeded, but you need to press that button within a specified time frame. So reaction speed is about 0.2 of a second, I believe. So the idea is you've got to press the number 1 button within 0.25 of a second, giving you a little bit of time. If you do that, then then the buzzer will sound and tell you that you've completed it. Maybe there'll be a little sequence of lights on the LED, and then you get the opportunity to play the game again. If you do that twice in a row, then the buzzer will sound twice in a row, 3 times in a row, 4 times in a row, and you understand what I mean. Right, let's get down to it. Okay, so it's changed a little bit. What I've done is I've got rid of our compare functions, and instead I've put this function in, which is called random. Now, don't be confused with the random command. It's a bit silly of me calling it this, but that is what my subroutine is called. It's random. It's the sort of randomizer, the compare function. Maybe I should have called it compare. And what else have I done? I've called it dice. I have put this in, which I think I had before actually, the randomizer, and I've put a second button in. Can you see? I've got PTM1, and if you're not pressing that, it's saying, well, are you pressing PTM2? So I've got both my buttons in, they're live now. Now, if you press the other one, it's just going to produce a random number, and then when you take your finger off of it, it's going to keep on producing random numbers until you take your finger off of it, and then it's going to go to the buzz subroutine, which is over here, and that's a buzz subroutine, the one we had in before, which is fine. I've also as you can see, put the compare. I've slightly altered it. Opposed to it going across from left to right, it goes up and down, but it's absolutely the same. That you've got all your different outputs here, and then you've got your return down here. So that is a subroutine called random, and you go through this, and then it will return to where it came from. So hopefully this should work. So let's just have a look. It's all on. Let's press this one. Well, yeah, okay. Yeah, 4, and then this one. Let's hope that was 1. We have to go over here actually. View inputs, view flowchart, unlock. Oh no, that's wrong. Variables. Yeah, it was a 1. Can you see down there? Oh no, sorry, it's that one. N equals 1. Let's just try that again. That was 2, I think. N equals 2. Yep. So that's working just fine. I'm going to call it there for the time being, but I just want to make sure that part of my program is working. So very quickly, I've just created a new little program here, which is if both PTMs are high. And so that's not right, is it? I think it is actually. No, it's not right. I've done this wrong. Apologies. I'll just modify it whilst you're with me. I want to ask it the question, and I use the wrong command. I use an output command. Digital is in there. I'm asking if 1 and 2, sorry about that, another error. If 1 and 2 are pressed, then I want to reset all of the flowcharts. And so that is if they're pressed together. If it's not pressed, it needs to go back around to the top. That's it. Okay, this is for the Snake Eyes game. And we need to record if a button has been pressed or not within the 0.25 of a second. And so this is just a really simple little program which starts, has D1 been pressed? That's the button we need to press. If it has, P equals 1. If it hasn't, well, P could equal anything else. It will be set at 0 really. So P will equal 1 or P will equal 0. We don't want a P equals 0 here, because if it did record it and we went back around to the beginning again and we took our finger off of the button, P would then equal 0 because it would be going through that expression. I hope that makes sense. So this is our recorder, and I'm going to call it a suitable name as well. So this is a truth table I've just created just to work out and explain what I'm doing in the next part of the program. If the random number equals 1 and P, remember that's the press little function, the pressed little program equals 1, therefore I've pressed the button within the 0.25 seconds, then I win. And if the number is anything else and I press the button, I fail. So there's only one outcome where I can win. And remember, if P has not been pressed, that doesn't mean that you failed. It just means that another number will be produced. Another random number will be produced. And so if you don't press the 1 when it's on, when a 1 pops up, it will then just produce more random numbers until you do press that button. It's not until you press that button that it will compare whether the n equals 1. If it doesn't equal 1, if it equals 2, 3, 4, or 5, or 6, you've automatically lost. And of course, that's the only way you can lose. That's correct. Because the other way is if P equals 0, but then it just goes round to the beginning again and makes more random numbers. So, okay, let's have a quick look at it. So we've got a reset on there. We've got our press function now. So to identify if the button D1 has been pressed. So let's just go out to the code, and we have this. These two functions. Is D1 on, and it goes and does the dice. If D2 is on, then it goes down to the next program or its other side, which is going to be, we should really call this selection, not dice, which is going to be the Snake Eyes. I'm starting off by making P0. So that means that we have effectively reset the value of P, because if P is 1, the button has been pressed. So P not being 1 means the button has effectively not been pressed, which is correct at the moment. We then randomize N, the number, and then we ask, is D2 off? So effectively we're doing the random generator now by the length of time that your thumb is on that button. We then produce a random, so another random, I shouldn't call it random, which is this. So we allow this flowchart to run its course. I shouldn't say that, I should say it's this subroutine to run its course. When it's run its course, of course, it will show a particular number on the display. So that has shown its course. It then, once it's done that, it will compare if P equals 1. If P does equal 1 at that point, you have pressed the button. And of course, if P doesn't equal 1, so if it equals 0, because it's set up here to be 0, it will then just go back to produce another random variable. And so you'll get random variable happening every 0.25 seconds. If it has been pressed, though, it will see if N equals 1. If N does equal 1, then you have pressed P when N was illuminated on the display, and therefore you've won. So internally, what will happen, it will increase the figure S by 1, and that will happen each time. It will then go S equals N. I've done that so we can use the other part of the flowchart to help us in building the buzzer. I'm not too sure. S equals, yes, from 1 to N. Yes, it will buzz N times. Can you see that? N from 1 to N. So effectively, I am swapping N's value with S's value, which is the number of sequence we've got, which is down here. And then I'm going to run, no, I said that, I'm going to run the buzz. I've just talked about that. And then we're going to go on to the high. If N is not 1 and you've pressed the button, what's going to happen is everything's going to go high for 2 seconds, and then everything's going to be going low for 2 seconds. So let's have a look at it. Oh, wrong one. Let's press our play, see what happens. Well, this one should be the dice. That looks pretty good, doesn't it? Absolutely fine. Right, this isn't all finished yet, but we can see all the different. What I don't like about that is it doesn't switch off. And so I am going to put probably a 0.1 second sort of delay in it where everything is switched off. Okay, sorry about that. Just having a look down here. We've got our is D2 pressed, and then we've got our randomizer, which is this bit here, isn't it? Got to make sure D2 is on, and then it's going to randomize until D2 is off, which is here. It then calls in this random subroutine, and the random subroutine is this one, the compare one with particular outputs going on. We then, once we've got the different output, we're going to wait 0.25 of a second, and we're going to compare. We're going to see what P equals. If P equals 1, it means it's being pressed. It means that button's being pressed. If P equals anything but 1, it means it hasn't been pressed. How did we do that? Remember, we did this little thing over here. P equals 1 when it's pressed on that little program. And then we're going to compare if P has been pressed and the number equals 1. So if it's been pressed and the number is 1, then you've won. Then your score, your sequence increases by 1. This is what this INC means. It means it will increase S by 1. And then we're going to use the buzzer, we're going to say S equals N. And the reason for that, of course, is we got our sequence over here, which is our end sequence. If I can get there, here we go. This is our end sequence, isn't it? Buzz is the same number of times as n, and so I'm just utilizing n to make that work, and then I'm calling in that routine, that subroutine with a buzz command. And over here, if p has been pressed, but n doesn't equal 1, so that equals 2, 3, 4, 5, or 6, we're going to send everything high for 2 seconds and everything low for 2 seconds, and then s is going to equal 0. And so I'm resetting s. The score of your sequence is being reset. Now this works to a degree, but it doesn't work very well at the moment, so I'm just going to go over and take a quick look. Here we go. I'm going to press, I think this one is there we go, is our dice functioning well. 5 and a 1, of course, was just rolled. Now I'm going to press this one, and what we've got is we've got a distinction between each number. It turns itself off in between each number. So I've got to try and hit this when it's a 1. Okay. Oh no, it's this one I've got to press, sorry. It's the other one. I'm going to hit it. Oh no, I did it wrong. Off it goes for 2 seconds, everything on for 2 seconds, and then the whole thing falls apart. So I've just got to work out. And the reason it was all falling apart is this simple. Can you see over here, p equals 1. So p's been pressed, whereas p should be 0. That's our problem at the moment. And so I've got to just reset p to 0, and then I think I'm going to be nearly there with only a couple of other modifications. Okay, a couple of last things I've done. To reset p to 0, I put p's down the bottom here. Otherwise, p was going to always be on 1. Another thing I've done is I put a wait command in here to 0.5 because I'm just not good enough to do 0.25. I'm sure you will be. And another mistake I made was I put s equals n. It was actually n equals s, isn't it? Increase s to the number, and then n equals that number. Can you see? And so I had it around the other way. So we go back to this, and we all know that if we press play, that the first one is going to be just fine. We're going to have a random rolling dicey thing going on. Yeah, and then this one, we press for the second game, and off they go, turning on and off the lights. And when it gets to 1, oh, can you see S over here has gone up to 1? S over here has gone up to 1. Let's see if I can do it again. Concentrate. It's over there, I was on 2, and now it will beep the number of times. I think I was on 3 then, just too late. Can't even do half a second. But I think that's the program. There is another rule in there that is the same number shouldn't be able to be shown twice, which I'm just going to work on now. And I'm sure that will be a couple of simple commands, that's all. And so either leave me here or come with me to the end. Okay, I've jigged this around a bit just to open up a little bit more room. But all we're really doing is putting or creating another variable to make it never display the same number twice. We've just got to compare a value to a previous value. So we've got to make sure that n never equals one of its directly previous values. Does that make sense? I think so. The way to do that is to get another variable m to equal n, and then compare it to m. And so what I've done here is I've got my compare n, which is the new value, to m, its previous value. The first time it goes through this, of course, it doesn't have a previous value, but that means it won't equal it, and so it will go through. And then here you can see what I've put in is now m equals the new value. But when we come back around and it reproduces another newer value for n, m still equals that previous value. Crikey, that is a mouthful. So hopefully you understand that, but we can see that if we go back to the circuit diagram and we press the play and we press our little friend down here, you can see we never get the same value twice. fantastic. And that's it. I think that is our Snake Eyes with a little scoring function as well, with a transistor, an NPN transistor, which operates the buzzer, and it's all there, which is absolutely fantastic. Well done for lasting this long.